Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at factorising. So what is factorising? Well, it turns out it is the opposite of expanding. See, in the last few lessons, we've been expanding. We've been going this way. We've started off with an expression that has brackets, ended up with something that didn't have brackets. Now we're factorising. We're going to start off with an expression that has no brackets, end up with something that does have brackets. Expanding and factorising undo each other just like multiplying and dividing. So if you multiply a number by 4, then divide your answer by 4, you're back where you started. Similarly here, if we expand an expression and then factorise it, we're back to where we started. So we call it factorising because when you factorise an expression, you write it as something times something. Just like if you factorise 36, you can write it as 9 times 4 or 12 times 3 or whatever. So we're going to start with expressions that look like this and write it as something times something, and we will have brackets in our answer. So there are a few different methods of factorisation that we will learn. The first we will go through is highest common factor, or HCF. So how we're going to do that, we're going to take our expression that has two terms and we're going to calculate the highest common factor of each term. Note that the highest common factor of each term, it could be a number, it could be a pronumeral or a letter, it could include both of those things. So all we do is write that highest common factor outside the brackets, and then inside the brackets we take each term and divide by the highest common factor. Probably sounds a bit complicated. Hopefully it'll be much clearer after we do some examples. So we're going to start by factorising 4x plus 20. We have two terms, 4x and 20. We want to find the highest common factor of these two terms. Well, the highest number that goes into 4 and 20 is just 4. That's sort of a factor they have in common that they both have. So the highest common factor is 4. We've done our first step. What we do now, inside the brackets, we divide each of the terms by 4. So 4x divided by 4. In other words, I'm saying, what do I times by 4 to get 4x? Well, you just times 4 by x to get 4x. What do you times by 4 to get positive 20? Well, you just times positive 5. So we're done. This is our answer. We've written 4x plus 20 as something times something. If I were to expand this using the distributive law, I would get this, because expanding and factorising undo each other. So you can always check your answer by expanding it and making sure you get back the original expression. All right, that's the first one done. Now let's look at this second question. So 12ab is one term, second term is negative 20b. We need to find their highest common factor. So the highest number that goes into 12 and 20 is once again 4, but they also have a pronumeral in common this time. They both have a b, so I'm going to write a b out the front. The highest common factor of these two terms is actually 4b. Now I'm not going to put an a out the front. A is not common. Only the first term has it. They don't have the a in common. So now, first step done, second step. I divide each of these terms by 4b. So 12ab divide 4b. I'm saying, what do I need to times by 4b to get 12ab? Well, I need to times by 3 to get to 12, and I need to times by a, so it's an ab. Now, what do I times by 4b to get negative 20b? Well, negative 20 divided by 4 is just negative 5. I don't put a b here, because I've already got the b. 4b times negative 5 is negative 20b. If I were to expand this, I'd get 12a minus 20b, the original expression. So let's now look at factorising some quadratics. These are quadratics because they have an x squared term. So here, two terms, x squared, negative 4x. What do they have in common? Well, they only have an x in common. There's no number other than 1, which doesn't really count, that goes into 1, this coefficient's 1, and negative 4. So the thing that these two terms have in common is x. So I write it outside the brackets. So now I say, what do I times by x to get x squared? Well, you need to times by another x. What do I times by x to get negative 4x? Well, that's just negative 4. If I expand this using the distributive law, I'm back where I started. All right, let's look at the last one. So 10x squared and 6x, what's their highest common factor? The highest number that goes into 6 and 10 is 2. But both of these also have an x in common, so I need to put that out the front as well. So what do I times by 2x to get 10x squared? I need to times by 5 to get to 10, and I need to times by x, so it's an x squared. 2x times 5x is 10x squared. Now I say, what do I times by 2x to get negative 6x? Well, I need to times by negative 3 to bring up the negative 6. I don't need to write an x. I already have it. 2x times negative 3 is negative 6x. So once again, if I expand this using the distributive law, 2x times 5x is 10x squared. 2x times negative 3 is negative 6x. If I expand this, I get this, because expanding and factorising are just opposites of each other. All right, let's now look at some harder examples where one of the common factors is a bracket. So how would we go about factorising something like this? Well, we're still using the same idea. It's like this is one term and this is another term. What's common to both of these is a plus 2 in brackets. So we simply write that out the front, a plus 2. Now, same idea as what we're doing on the previous slide. What do we times by this highest common factor to get the first thing? Well, a plus 2 is being multiplied by 3, so I'll put a 3 in there. What do I multiply by a plus 2 to get the second thing? Well, in this second term, a plus 2 is being multiplied by negative b. So this here can be further factorised into something like this. If you were to expand this and expand this, you would get exactly the same answer. So how would that apply to something like this? Well, here we have 4 terms. What we can sometimes do is factorise the first 2 separately and then factorise the last 2. So let's factorise the first 2. X squared minus 8x. Well, the highest common factor is x. What do I times by x to get x squared? What do I times by x to get negative 8x? Now let's look at the next 2. So the highest common factor here is 4, but I'm going to take out a negative 4. So if this third term here is negative, we always want to take out a negative factor. So what do I times by negative 4 to get negative 4x? Well, I just times by x. What do you times by negative 4 to get positive 32? Well, I get negative 8. Now you can see we've got something that looked like the previous question. Here it's like first term and second term. What is common to both terms is x minus 8. So we write that out the front. What do you multiply by x minus 8 to get this first term? Well, it's being multiplied by x. What do you multiply by x minus 8 to get the second thing? Well, it's being multiplied by negative 4. So if you were to expand this using the distributive law, you would get that. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.